Magma oceans, supersonic winds, scorching hot days, and instead of rain, a bunch of rocks falling on your head. Just another one of those days, huh? Astronomers recently discovered a new superplanet out there. K2 414b is an exoplanet that's around 200 light-years away and in serious need of a new name. An exoplanet is just a fancy way of saying that a planet orbits its own star in another solar system. The Earth orbits the Sun, so this planet has its own orbit party going on. So what makes K2, bunch of numbers, so scary? Picture our beautiful little blue planet Earth. Now imagine that all the volcanoes in the world suddenly erupted at the same time and lava covered the oceans and seas. Fiery hurricanes, thousands of times faster than normal, blow all over the place, 24/7. And it starts raining rocks every now and again. Rocks, like on your head. Thankfully, not in your head. This scary planet came into our lives about 2 years ago. Scientists are still studying it. So, what's a typical day like? For starters, you can forget about breathing. Oxygen decided to take a pass on this planet. You'd have to get used to sodium, silicon monoxide, and silicon dioxide, which is, as you guessed, not great. And that's just scratching the surface. Who knows what other chemicals are lying around? And yes, magma oceans. The planet's surface is covered in molten magma as far as the eye can see. This lava planet orbits really close to its star, which is why the surface is like a fireplace. The closest planets to our Sun are Mercury and Venus, but this planet's even closer. And what's even more weird is that half the planet is in constant daytime, the other half night. It's tidal locked, just like our moon is. No matter how long you stare at it, you'll never see the other side. That's why the all-day, everyday scorching fiery side is so hot and overflowing with magma oceans, while the other side's in a constant state of deep freeze. If the magma doesn't burn you, you've still got big problems, and please don't look up, it's raining rocks. On Earth, water turns to steam, rises up, becomes clouds, cools, and falls as rain. Over there, on planet Fireball, it's exactly the same, except for it's rocks, people. The planet's so hot, it vaporizes rocks. Oh, and don't forget the supersonic winds with speeds up to 3,000 miles per hour. Imagine your hat getting blown off your head at 5 times faster than an airplane. The strongest wind on Earth was the tropical cyclone Olivia that hit Australia. It was blowing at 250 miles per hour. Now imagine 12 times that. On the sunny side of the planet, you're looking at a roasting 5,000 degrees. The hottest it ever got on Earth's surface was in California, 135 degrees. It's pretty common for it to get near that temperature in the Sahara Desert, but that kind of heat's not exactly enough to make rocks evaporate. If you grew up near a desert, you already know how dry and hot it always is. But did you know that deserts can reach freezing temperatures? A desert, by definition, is a large area with little or no rainfall. That means no water vapor to keep the temperatures from going insane. In the daytime, the sun heats up the desert like an oven. But when the sun sets, the heat packs up and heads home, and it can get really cold. Some deserts have even reached minus 40 degrees at night. But wait, shouldn't deserts have snow if it's that cold? Well, some deserts have had a bit of snow here and there, but because there's no water vapor, there can't be that much snow. Just dry, freezing, sandy Sahara nights. Now, the Sahara Desert's actually not the largest desert on Earth. It's Antarctica. 5 million square miles of icy dryness, almost no people, and a whole bunch of cute penguins. Penguins technically live in a desert. Back to the Fireball planet, this time the night side. Never-ending darkness and extreme cold, about minus 330 degrees. Add in some supersonic winds? Earth's coldest? Minus 130 degrees at a research center in Antarctica. So, how does this jalapeno pepper exoplanet stack up against some of our neighbors? Well, Mars isn't exactly livable either. It's the red planet, so you'd think it'd be hot most of the time. But it's usually freezing, well, way below freezing. And if you're planning a weekend getaway to Mars, you can leave the umbrella at home. Nah, it doesn't rain rocks, and it actually hasn't rained there for millions of years. At least Mars has days and nights, and it's like Earth in other ways. Mars' equator is steamy hot, and it gets pretty cold at the north and south poles, just like Earth. Scientists even discovered old bits of carbon dioxide snow there. The entire planet is actually covered in carbon dioxide, with a splash of nitrogen here and there. Scientists even reported intense snowstorms on Mars, but because it's mostly carbon dioxide, it's not your typical snowstorm. It's more like a dry ice storm. That's the stuff they use in fog machines. Mars isn't the only place where climates are going cuckoo. Jupiter's famous for its gigantic storms. Not like the ones we know on Earth. I'm talking about storms that last for centuries. The Great Red Spot on Jupiter is actually a 400-year-old storm, and you could fit 4 whole Earths inside of it. So it's been around for a while, but it's nowhere near as intense as the storms on K2. Venus also has intense rain, but it's not made of rocks. It's sort of worse. It rains sulfuric acid. That stuff can give you severe skin burns and rip nasty holes through your umbrella. Venus's atmosphere is filled with carbon dioxide, which acts like a net to trap in the sun's radiation, and it's insanely hot. No magma oceans, though. Mercury is the closest planet to the sun and doesn't even have an atmosphere. That means no storms, clouds, rain, wind, whatever. Mercury is kind of like a desert here on Earth. No water vapor and no rainfall. That means temperatures shoot up during the day and drop like crazy at night. The K2 exoplanets, like the most extreme parts of all of our solar system, all rolled into one scary planet. But we're not headed there anytime soon. We haven't even been to Mars yet. That's all way off in the future, and 200 light-years is a really long travel time. If we're going to move anywhere anytime soon, we'll probably want to set up camp on the moon. No magma oceans, no warp speed winds, nice temperatures. So, where would we even start? Well, the main issue is that drones and remote control robots are getting more and more advanced. It's way cheaper to send them over to map out the moon for us while we're safe here on Earth. And if we ever want to begin space exploration for real, we'd need a proper space base. And what better place than our little shiny moon? So, why do we even study those far-off planets? What's the point? Well, planets are like people. They're all different ages and live in all different places. The more of them we study, the more we can understand why there's life, aka us, on Earth and not on any other planet so far. When we see crazy new planets, we get crazy new ideas, which can turn into awesome inventions that make our lives easier. Even just going into space gives us new ideas. Scratch-proof lenses, some firefighting equipment, water filtration systems, wireless headsets, invisible braces, that tiny vacuum you use to clean those crumbs in from between your couch cushions, they were all invented to help astronauts work better in space. And now they make our lives better every day. Maybe we'll figure out a new energy source someday, thanks to a far-off planet or star. Or we might discover a new compound that will make our buildings stronger or more energy efficient.
You may think the Earth is pretty big, but the Sun makes up almost 99.9% of the mass of the whole solar system. The rest of the mass is made up by the planets and their satellites, asteroids, comets, gas, and dust. It's around 93 million miles away from our planet, but it keeps us warm every day. Its temperature is about 10,000 degrees Fahrenheit, but the space surrounding it is still cold as ice. To understand this, we need to distinguish between heat and temperature. Heat is the energy inside some object. Temperature is something that tells us if that object is hot or cold. When the heat is transferred to that object, it makes its temperature go up. When the object is losing heat, the temperature goes down. Heat can be transferred in 3 different ways. The sun does it through radiation. That means it's releasing heat in the form of light. Your body radiates heat too, as infrared waves. That's why thermal imaging cameras will detect that you're in the room even at night. The hotter the object, the more heat it will radiate. The temperature only affects matter. Since space is mostly a vacuum, it doesn't have enough particles for heat to transfer in any other way than through radiation. When the heat from the sun gets to an object, the atoms start absorbing energy, but the heat can't transfer since there's no matter in space. Those rare atoms and molecules in space will absorb the heat. And they'll simply stay that way, while the cold vacuum will stay cold. There's a lot of matter inside Earth's atmosphere, so the energy of the sun can transfer easily. But if you put an object outside of the Earth's atmosphere in direct sunlight, it would end up heated to 250 degrees Fahrenheit because it's matter made of atoms and molecules. The temperature of the vacuum is negative 454 degrees Fahrenheit. That means, depending on where you are, space can either burn or freeze you. The sun isn't actually yellow. It emits light over a wide range of wavelengths. We can tell both its temperature and color by the peak in its spectrum. For instance, cooler stars will appear red, and hotter stars will be blue with yellow, orange, and white stars in between. When it comes to the sun, the spectrum peaks at a wavelength we'd usually call green, but our eye perceives it differently. So, the shade of green in combination with other wavelengths from the spectrum is going to look white to the human eye. We generally see the sun as yellow because our atmosphere scatters blue light more efficiently than the red one. During sunrise and sunset, there's more red light in the spectrum of the sun, which gives us amazing sceneries. Sunspots are part of the sun's visible surface that are on average way cooler than the sun itself. They overlap with parts that have an increased magnetic field. These parts don't allow the release of heat to the sun's visible surface. That way, the rest of the sun's surface is 3 times brighter than those sunspots. That contrast makes them appear almost black. If we could take a sunspot apart from the sun and place it somewhere in the night sky, it would be different, as bright as the moon when we see it from the Earth. All the planets in our solar system spin in the same direction because they were formed from one protoplanetary cloud, except for Uranus and Venus. They have probably had some strong impact on them that made them spin in the opposite direction. But it's different with galaxies. They don't usually form the same cloud of dust and particles. Also, they're not randomly distributed across space. They come in filaments, dense, slender strands of dark matter and galaxies, with voids in between. Proto-galaxies are linked by gravitational forces in small areas of space. This is probably because of the distribution of dark matter throughout the universe. The matter in the filaments moves in a corkscrew motion and goes towards the densest area. So, there might be a common direction galaxies tend to spin, but it's mostly random. There's a possibility we'll see a lunar elevator one day. Yep, a cable anchored to the surface of the moon. It would stretch 250,000 miles. We wouldn't be able to directly attach it to our planet because both Earth and the moon are moving. But we could keep it terminated high in our planet's orbit. Some researchers believe we could build such an elevator for a few $1 billion. The moon has resources we could definitely use. A rare form of helium found there could be of use in fusion power stations on our planet. Also, we could take some other rare elements and use them in smartphones and the rest of electronics. So, after around 53 trips up and down, the elevator could pay for itself. The cable would be as thick as a pencil, but its weight would be around 40 tons. It could even be made of materials we already have here on Earth, with no need to invent something. There could even be a combination of 2 elevators. A spacecraft would winch up an elevator from the surface of our planet to a space station. Then it would be flung towards the moon. There would be another elevator to finally lower it down to the surface of the moon. Planets in our solar system have predictable and stable orbits, but gas-giant collisions could have happened at an early stage when a planetary system was still forming. In case of a head-on collision, 2 gas giants would merge. They wouldn't end up losing their mass, the materials in their gaseous envelopes, or the ones in their solid cores. Such a collision at a higher speed would cause the loss of the major part of the envelope gas, and very high speeds, boom, both planets are gone. It's different if it's not a head-on collision. If two cores manage to completely avoid each other, gas giants won't merge, but they'll lose some of the mass. Gas giants might even change their shape due to such collisions. Astronomers found out there's a galaxy extremely far away from us that looks similar to our Milky Way. We now see it as it was when the universe was only 1.4 billion years old, and now it's 13.8 billion years old. It took over 12 billion years for the light to come from this faraway galaxy and reach our planet. This galaxy is peaceful, stable, and surprisingly non-chaotic, unlike all other galaxies that were quite turbulent in their early stages. To leave the Milky Way, we'd have to travel around 25,000 light-years away from the center of the galaxy, or 500 light-years vertically. Our galaxy is a disk of stars that spreads around 100,000 light-years across and is 1,000 light-years thick. The Sun, its central star, is located halfway from the center of the galaxy and close to the middle of the disk in the vertical direction. We'd have to go further than its edge to get away from the halo that surrounds the Milky Way, old stars, diffuse gas, and globular clusters. If you wanted to go even further to see the Milky Way in all its glory, you'd have to travel 48,000 light-years vertically. At this moment, we don't even have a telescope we can send there. There are central stars that eat planets. Our solar system is stable, unlike many other planetary systems, so we don't have to be afraid the Earth or some other planet will change its orbit and go towards the Sun. But at least a quarter of other planetary systems with orbiting stars similar to the Sun have a pretty chaotic past. In some of them, there are planets that used to move around, and their unpredictable migrations have disrupted the paths of some other planets, or even pushed them outside of their orbit. That means some planets probably have fallen into the central star. When that happens, the planet gets dissolved in the outer layer of the star, which means it gets eaten. The moon's volcanoes are not dormant, and they can erupt any minute. For years, we lived knowing nothing about it, but now it's officially proven thanks to China's Chang'e 5 mission's shocking discovery. The lunar soil samples it brought back to Earth contained something absolutely unexpected, hinting that volcanic eruptions may have occurred on the moon as recently as 123 million years ago. Geologically, that's practically yesterday. But the big question is, are we safe down here on Earth? We've long known that the moon was once volcanically active due to the dark regions, lunar maria, on its surface. These maria, the dark plains that give the moon its characteristic markings, are ancient lava flows that date back to around 3 to 3.8 billion years ago. Until recently, scientists thought that those ancient flows marked the end of the moon's volcanic activity. But the Chang'e 5 mission brought back lunar soil that included several microscopic glass beads, and 3 of them in particular revealed an extraordinary story. They formed around 123 million years ago from volcanic eruptions. An uncertainty range is a mere 15 million years. The discovery of those tiny beads is super important because of their composition and rarity. Measuring between 20 to 400 microns, which is smaller than a grain of sand, these beads are volcanic in origin. And this fact sets them apart from most other lunar glass beads, which typically form due to meteor impacts. Impact events on the moon create glass by melting surface rock with incredible heat and pressure. The result is tiny glass beads scattered all over the landscape. Yet, the volcanic beads identified in Chang'e 5's sample were formed by magma erupting from beneath the moon's crust and cooling it into glass as it reached the surface. By using uranium-lead dating, which measures the decay of uranium into lead within the beads, scientists managed to pinpoint their age with striking accuracy. The results suggest that the last known volcanic activity on the moon happened within the past 200 million years, making it a recent event in the moon's long history. This discovery also aligns with prior observations of unusual surface features known as irregular mare patches. Those are smooth mounds surrounded by rocky terrain. They were first spotted by NASA's Lunar Reconnaissance Orbiter in 2014. These patches appear much younger than other lunar features, potentially formed by volcanic eruptions less than 100 million years ago. Before Chang 5's glass beads, these irregular mare patches were among the best evidence of recent volcanic activity on the Moon. Yet, without confirmation, their origins remain uncertain. And now, the glass beads confirm volcanic action. The findings raise new questions about the Moon's inner workings. In particular, how could it retain enough heat to sustain volcanic eruptions? We thought that the Moon had cooled significantly after its formation 4.5 billion years ago, which made it volcanically inactive. And without tectonic activity or an atmosphere, the Moon should have shed its internal heat long ago. Yet the beads suggest the possibility of some localized heat sources within the Moon's mantle. Scientists think that heat-producing elements such as potassium and thorium might be creating small, warm pockets which generate enough heat to melt rock and trigger isolated volcanic eruptions. But wait, beyond rewriting the Moon's history, this discovery adds an intriguing twist to ongoing studies of transient lunar phenomena. These sightings, often reported as ghostly glows or hazes by amateur astronomers, remain unconfirmed by scientific probes. Some experts just dismiss them as illusions caused by Earth's atmosphere. But if the Moon has small pockets of volcanic or outgassing activity, TLP might have a real basis. Gases emitted from beneath the surface could explain such mysterious glows and possibly be a hint of residual volcanic action on the Moon. Now, if volcanic activity still lingers on the Moon, this might have exciting implications for future lunar missions. In the coming decades, astronauts might be able to use volcanic heat for generating power, melting ice into water, or even warming bases built into the frigid lunar surface. But recent geological discoveries aren't limited to Earth's natural satellite. We learn more about volcanic moons beyond our solar system too. The detection of a possibly volcanic exomoon orbiting exoplanet WASP-49b around 635 light-years away means that volcanic activity may be a common feature among moons. Up until now, Jupiter's moon, Io, held the title of the most volcanic body we know about. But researchers at NASA's Jet Propulsion Laboratory may have found a new candidate. This potential exomoon came to light when scientists observed a cloud of sodium gas around the exoplanet. But the thing is, sodium clouds are unusual in planetary atmospheres and can suggest volcanic activity. The sodium cloud near WASP-49b had a bizarre, unexpected behavior. It was moving erratically, shifting size, and occupying a space too large to be explained by the exoplanet's own atmosphere. Scientists thought the cloud could actually be generated by a volcanically active exomoon in orbit around WASP-49b. Volcanic moons like Io are known to release gases such as sulfur dioxide, sodium, and potassium, which form massive clouds around their parent planets. Io, for instance, regularly produces vast amounts of gas that form a cloud encircling Jupiter, up to 1,000 times the size of the gas giant itself. If something similar occurs near WASP-49b, the gas cloud could be a clue to volcanic activity on an exomoon orbiting the planet. Observations from the European Southern Observatory's Very Large Telescope in Chile seems to confirm this theory. The sodium cloud around WASP-49b is positioned high above the exoplanet's atmosphere and behaves in ways that don't match the exoplanet's 2.8 Earth day orbit. This could suggest that it originates from a separate body, likely a volcanically active moon. Additionally, WASP-49b and its host star consist primarily of hydrogen and helium, which makes the sodium cloud even more unusual. The observed rate of sodium release, over 220,000 pounds per second, can be a sign of an immensely powerful volcanic source. If scientists verify the existence of this exomoon, it would be the first discovery of a volcanic exomoon. Back in our solar system, Io remains the main space object, helping us understand volcanic moons. Recently, NASA's Juno spacecraft provided some of the closest images of Io since the Galileo mission over 25 years ago. Io's intense volcanic activity is caused by tidal heating, the result of the gravitational pull of Jupiter and nearby moons, like Europa. This tug-of-war generates immense friction within Io, producing heat that fuels continuous volcanic eruptions. One of Juno's most exciting recent findings was a new volcano that appeared just south of Io's equator. Juno's images show a large, complex volcanic region, approximately 111 by 111 miles in size. The craziest thing? It wasn't there when Galileo imaged the same spot in 1997. This new volcano formed near the previously known volcano Pamukkale. Researchers say that this new volcanic structure is a great change that highlights the dynamic nature of Io's surface. Io's equatorial region is home to most of its volcanoes because of the concentrated tidal heating it experiences. The most powerful eruptions emit sulfurous gases and produce bright lava flows. They cover the moon in colorful, sulfur-rich deposits. JunoCam's image, taken from about 1,570 miles away, shows Io dramatically lit by sunlight reflected off Jupiter. And you can see a stunning view of its constantly changing volcanic surface. Despite these detailed observations, there are still many mysteries about Io's volcanism. Scientists are particularly curious about how tidal heating affects Io's interior, and whether it has a subsurface magma ocean. Plus, researchers try to understand what triggers different types of eruptions. For example, plumes versus lava flows, and how volcanic gases shape Io's surface and thin atmosphere. The study of volcanic moons from Io to the possible exomoon near WASP 49b sheds light on how tidal forces create volcanic activity in different moons. In icy moons like Europa, tidal heating sustains liquid oceans beneath the surface, creating potential habitats for life. But for Io without an ocean, the same forces instead generate powerful volcanic activity. Plus, if volcanic exomoons do exist, like the one possibly orbiting WASP 49b, we might soon discover more volcanic bodies across the galaxy.
Extremely hot and insanely fast. Yeah, that's me. Oh wait, you mean the space thing. Okay, first, they discovered PEG 51, an exoplanet that orbits a star similar to ours. An exoplanet is any planet outside of our solar system that orbits a star that's not the Sun. This planet was completely different from anything we've ever found. Almost the same diameter as Jupiter, but half the gas giant's mass. It took only 4 days for this exoplanet to orbit its star, which seemed impossible. It was definitely too fast for something so massive. And then, scientists started finding something they've named hot Jupiters all over space. Lots of heated gas giants were located only a couple of million miles away from their stars. Sometimes, there were a couple of space bodies orbiting their stars pretty closely, and many were a few times bigger than Earth. Solar systems where they found hot Jupiters are not like ours. We have a neat system with smaller rocky planets on the inside and big gas giants on the outside. And almost all of them peacefully orbit the Sun, following their trajectories. Everything is in order. When a star is at the earliest stage of its formation, it creates a disk of gases, debris, and dust surrounding it. It's called an accretion disk. These gases slowly get pulled into the star because of its gravitational forces, and this leads to some kind of a stellar whirlpool. The outer parts of the disk are more gas-dense than the center. With time, the whirlpool effect gets even stronger. The same thing happens with hot Jupiters, which causes these gas giants to start orbiting much faster than usual. This also carries it further toward the star in a tightening spiral. Luckily, our Jupiter didn't become a hot Jupiter. Our gas giant started its life as an icy Earth-sized asteroid, which is different from the way hot Jupiters form. During the time when it was forming, Jupiter was around 4 times as far from the Sun as it is today, somewhere between Uranus and Neptune. About 2 to 3 million years after Jupiter first formed in the accretion disk of our Sun, it started a 700 million year-long phase astronomers call the Grand Tack. Now, tack is something a boat performs when going towards a buoy and then slipping past and around it. Then it speeds up and goes in the direction where it came from. That was the same thing Jupiter started doing, and in its tightening orbital migrations, the planet's gravity could have moved many asteroids and other space bodies, distorted the orbits of larger planets, and caused collisions and chaos. Jupiter's Grand Tack would have destroyed many big space bodies. It's a could-have-been scenario, but luckily, Jupiter changed its course and became a peaceful gas giant. Neptune, Uranus, and Saturn were starting their own version of this chaotic process. Saturn even got so big that its gravity started pulling Jupiter away from its orbit. But after some time, these gas giants' orbits became locked. Then both of them managed to clear away the gases remaining between them. And since these gases were some sort of fuel for the planet's migrations, Jupiter and Saturn could both finally settle into the stable orbits we know today. Jupiter can still lob 1 to 2 icy asteroids at the inner planets from time to time. But when our planet was younger, this could have been one of the processes that formed the oceans on Earth. But Jupiter is much calmer these days. Saturn's gravitational forces have moderated the situation and are now keeping it under control. Now, Jupiter is our protector. It's 2.5 times the mass of the other planets of our solar system combined. It's some sort of a gravitational shield orbiting around the inner part of the solar system. Jupiter redirects incoming debris and asteroids away from the inner planets, Mercury, Venus, Earth, and Mars, keeping us all safe. Because of this, Earth has always been protected, so our planet has had enough time to evolve complex life forms. And it hasn't been destroyed by asteroids, hot Jupiters, or other space bodies. Jupiter wasn't the only planet that could have collided with Earth. Scientists think Mercury might have been involved in a hit-and-run accident with our planet. Mercury is the innermost planet in our solar system. It's the closest to the Sun and the smallest planet out there. And it also keeps getting smaller. Nowadays, its diameter is around 9 miles smaller compared to its size 4 billion years ago. Scientists think this might be happening because the planet's core is made of iron, and this iron is cooling and becoming solid, which is slowly reducing the planet's size. Mercury is the planet with the biggest number of craters in our solar system. Its atmosphere is really thin, so it can do nothing to keep the planet protected from meteors. The largest crater on Mercury's surface is at least 963 miles across. It could fit Western Europe from Germany to Portugal. The object that formed such a crater must have been at least 62 miles long. With all these craters, Mercury looks similar to our Moon. It orbits the Sun faster than the other planets, so 1 year on Mercury lasts around 88 Earth days. That means celebrating a birthday every 3 months or even more often. At the same time, the planet rotates so slowly that a day on Mercury lasts almost 59 Earth days, a long time to wait to go to bed. There's a piece of Mercury on our planet. In 2012, a green meteorite was found at a street market in Morocco. Scientists studied its composition and concluded it could be from Mercury. Mercury doesn't have its own moons because of its small size and weak gravity. Plus, the planet is too close to the Sun. By the way, the only other planet without moons in our solar system is Venus. Mercury has a really thin crust, like a good pizza. One of the theories of the planet's formation claims there was a major collision where the planet lost most of its crust. It could have also moved Mercury from its original spot. It wouldn't be unusual. The gas giants in our solar system also didn't form in the location where they are today. Mercury also has an eccentric orbit, which means it could have been kicked out of its old orbit and moved to a new one. Scientists also think Mercury might have collided with the early Earth. One theory says that's how the Moon could be formed, out of all the material flying away after the big crash. There might even have been pieces of Mercury's crust in the mix. Exoplanets Kepler 107b and Kepler 107c are a pair of planets that orbit a star similar to our Sun in the Kepler 107 system. It's around 1,700 light-years away from us. These planets have almost identical sizes, both with a radius 1.5 times that of Earth. But one of them, Kepler 107c, is almost 3 times as dense as the other. That's because the planets have a different composition. Some scientists believe that Kepler 107b is less dense because it probably collided with another unknown planet in the past. This powerful hit took away part of its surface and left behind a very dense core rich in iron. A huge comet hit Neptune around 200 years ago, but since Neptune isn't a rocky planet with a thin atmosphere like Mars or Mercury, it's harder to find evidence of this impact. But a comet called Shoemaker-Levy 9 broke apart in 1994 and smashed into Jupiter. Astronomers managed to record this event. It helped them learn more about the elements and molecules the collisions left in Jupiter's atmosphere. This information helped scientists realize that the amount of carbon monoxide in the upper layers of Neptune's atmosphere is higher than in the lower ones. This means a big comet likely hit the planet in the past, since comets have carbon monoxide in their icy tails. Something huge slammed into Uranus, too, changing the planet forever. A space object twice bigger than Earth hit the ice giant. This left the planet tilted, and it looks as if it's rotating on its side. Uranus is extremely cold, way colder than it's supposed to be. It might mean that the object that slammed into it was probably a young protoplanet made up of ice and rocks. Also, some of the debris from that collision may have created a thin shell around Uranus. It still traps the heat coming from the core of the planet. There are strange energy pulses bombarding our entire galaxy, and they come from the other side of the universe. Over the last decade, scientists have been observing bizarre flashes of light coming toward our planet. This phenomenon is called fast radio bursts, or FRBs. These signals travel through a couple of billion light-years of dust and gas. That's a rather long way. So far, no one has figured out what's going on behind these bursts. Massive tsunamis, destructive tornadoes, giant meteorites, devastating earthquakes. Ooh, better have insurance. But all these are minor natural disasters compared with the eruption of a volcano. Some volcanoes can destroy a city, as it was with Pompeii, or some islands in the Pacific Ocean. But there's a dangerous type of eruption that can destroy all life on the planet. This type is called flood basalt. But first of all, let's figure out what a volcano is. Rivers of hot liquid metals and incandescent rocks flow deep inside our planet. And the deeper it gets, the hotter they are. The source of this hot mass is the mantle, which is the middle layer of Earth, located between the core and the crust. These fiery streams are called magma, and it flows everywhere. But we don't feel its heat because of the thick layer of our planet's crust. Magma is lighter than the crust, so it always tries to break out to the surface. And in some places, it succeeds. At the junctions of tectonic plates, it splashes out when one plate moves under a thicker one. When magma reaches the surface, it becomes lava. This substance burns the ground around and cools down quickly. It hardens and forms a new layer of rock. The following splash of magma falls on the top of this layer. Thus, a mountain appears layer by layer over millions of years. And in its mouth, a fault of tectonic plates splashes out magma. This mountain is called a volcano. It spits lava and ash into the sky, then falls asleep and wakes up again during seismic activity. Now imagine that several giant volcanoes begin to splash out an infinite amount of magma. It just doesn't end and covers an entire continent. This is a flood basalt, and one day it did happen. About 252 million years ago, in the northern part of our planet, a lot of magma accumulated under Earth's crust. Trillions of tons of hot rock were concentrated in one place on a gigantic territory. And gradually, all this fiery energy began to seep out of the ground. Hot gas started to come out in different places in this territory. The ground shook endlessly, and the crust rose hundreds of feet. all pointing to the approach of an imminent catastrophe. And then, at some point, magma began to pour out. Giant fountains of fire burst out of the ground. Do you know these geysers in Iceland? So imagine the same things, but dozens of times higher and with hot lava and ash instead of water and steam. The ash and lava flows were so strong that they reached the clouds. Under Earth's crust, there was a gigantic bubble of magma, and it squeezed out fiery jets under the pressure of rock and ground. The rift was getting bigger. Magma was flowing out everywhere. It began to fill the entire North Continent. The flood of lava spread wider and wider. The streams of molten rock seemed endless. Layers of molten basalt rock overlapped one another, forming a giant tsunami of lava 160 feet high. It poured out of the ground for hundreds of thousands of years, flooding forests, rivers, lakes, and meadows. At the same time, billions of tons of volcanic ash rose into the sky, which could lead to a volcanic winter, since sulfur dioxide in the ash reflected the sun's rays. This might have lowered the temperature on the continent by several degrees. Then, dust and ash probably condensed and formed giant clouds that watered the surface with toxic acid rain. But after that, the cooled lava formed a giant thick shield, preventing magma from seeping out of the endless fire bubble. The global catastrophe was over, but only for a short time. Trillions of tons of magma were still flowing under a thick layer of solid basalt. The fiery rivers couldn't reach the top, so they spread out to the sides. As a result of this expansion, huge nets were formed under the thick rock. They ran in different directions like a spider web and heated Earth's crust. Gases started coming out from under the surface again. More and more energy accumulated there, until an explosion of unimaginable force occurred. In addition to magma, carbon dioxide and ash escaped to the surface. They filled the atmosphere and caused the greenhouse effect. The temperature on the whole planet increased by several degrees. This release provoked another catastrophe that began in the ocean. There were deposits of methane, an explosive gas, on the seabed. Under ice-cold water, the methane was frozen and harmless. But the greenhouse effect in the atmosphere warmed up the entire ocean. Millions of tons of methane began to rise to the surface. This gas is more potent than carbon dioxide. Therefore, when it hit the atmosphere, the temperatures on Earth increased again. The whole globe turned into a hot sauna. In previous cool and humid places, the temperature reached those of a modern Sahara. Of course, most animals and insects couldn't survive such a cataclysm, but ocean life took much more damage. The heat and methane reduced the amount of oxygen in the ocean. Fish and other marine life couldn't survive in such conditions. New problems appeared when anaerobic bacteria started to multiply in non-oxygen water. They fed on methane and carbon dioxide and released hydrogen sulfide, a toxic substance that poisoned water even more. About 75% of land animals and 95% of the ocean's inhabitants went extinct. This flood basalt eruption was the only disaster in the planet's history that destroyed almost all plants and significantly reduced the insect population. Several species of the hardiest animals managed to survive in these conditions. The planet took about 10 million years to recover completely. After that, evolution began a new process of developing life. And here are two pieces of news. The bad one is that flood basalt will happen again and will be no less devastating than 252 million years ago. The good news is that it will happen in hundreds of millions of years. But when that happens, humanity will need to be prepared. It will start on the ocean floor. First, lava fountains miles high will begin boiling the water and emit sulfur dioxide into the atmosphere, where it will reflect sunlight. Along with ash and magma, a massive amount of water vapor will rise into the air. Livestock won't survive, and people will have breathing problems. Acid rain and increased humidity caused by the evaporation of the oceans will lead to the corrosion of buildings. All flights will be canceled. People will have to wear gas masks. Many animals won't be able to handle this eruption, but humans will adapt quickly. But then another and another eruption will follow, and this endless catastrophe will soon deplete the resources of humanity. plants and trees won't recover so fast, and oxygen production will be significantly reduced. Let's hope that humanity will have colonized other planets, including those outside the solar system by that time. And now, let's jump back to the present. About 70% of the seismic activity associated with volcanoes occurs underwater. So let's see how ordinary volcanoes on the ocean floor work. Water, as well as land, rests on tectonic plates. Therefore, if their structure is broken at the joints, magma seeps through them. But unlike terrestrial volcanoes, lava here doesn't spread in different directions, burning everything it meets. It solidifies under the pressure of cold water. Underwater volcanoes can erupt for a long time with breaks in between. Magma covers the seabed. After another 100 or 1,000 years, a new eruption begins and a new layer of rock forms over the previous one. Over millions of years, layer by layer, magma is rising. And then, one day, a volcano rises out of the water. Magma splashes out of it and increases its height. And now we have a large volcanic island. Then the volcano falls asleep and life appears on the newly formed piece of land. Magma flows from the planet's mantle, filled with various chemical elements. This hot mix saturates the soil with useful substances and thus promotes the growth of plants and trees. Then birds and other animals arrive there, and the volcanic island turns into a paradise. Then humans arrive and pave over paradise to put up a parking lot and a franchise burger joint.
The Moon has long been believed to have formed as a result of a humongous impact with the Earth. A Mars-sized celestial body could have driven itself into our planet and made part of its crust shatter. The resulting debris then packed together in a tight ball, which later became our Moon. But there's one question that's been bugging scientists. The Earth's crust is poor in metals, so how come the Moon has so much metal within it? The latest research basically throws the main theory out the window, so we again know nothing about our closest neighbors coming to existence. On the Moon, iron is preserved in pristine condition because there's no oxygen. It simply can't rust there. But a couple of years ago, scientists made an unexpected discovery. In the higher regions of our satellite, iron is oxidized and actually rusting. At first, this finding perplexed astronomers to no end. The presence of rust might mean people can breathe, at least in certain areas of the Moon. But then the explanation surfaced. Oxygen might have got to the lifeless rock from our own planet. In the absence of atmosphere, solar winds beat the Moon relentlessly, and nothing can stop them. These flares could swoop some oxygen from the upper layers of the Earth's atmosphere and carry it all the way to the Moon. The molecules then come to rest at the highest points of the Moon's surface. That would explain why metals don't get oxidized in the ravines, and especially under the surface of the satellite. Water on Earth is actually a puzzle shrouded in mystery and covered with riddles. The most popular theory is that it was brought to our planet by icy comets and asteroids that left behind not only mighty craters, but the liquid substance, thanks to which we can now thrive. But there's a new advance which suggests another scenario. In space, there's a whole lot of organic matter, and under specific conditions, it could yield so much water, it would be enough to fill our oceans 1,000 times over. Researchers conducted an experiment in which they heated this organic matter and obtained clear water and oil. If this is confirmed in future studies, it could mean that even oil appeared on Earth, not only thanks to fossilized remains of living beings, but came from outer space as well. The climate changes we're witnessing are most probably part of a natural cycle. Researchers from the University of California, Santa Cruz have devised a pattern in our planet's climate variations, and they look like extremely long seasons. Sometimes, these states could last for millions of years, and they're all related to how the Earth is positioned relative to the Sun. The seasons were dubbed Ice House, Cool House, Warm House, and Hot House, according to the prevalent temperatures. For the past 3 million years, for example, our planet has been in the state of Ice House, since the last ice age was not so long ago. But humanity's actions, adding to the greenhouse effect, have pushed the climate state to Warm House much faster than it would have come without us. When it finally comes, the overall temperature on Earth will rise to tropical values. something that the planet hasn't seen in over 50 million years. What a time to be alive! Back to the moon now. You can see it at different places, in different sizes, and even in different colors every night. The size and location are pretty easy to explain. As the Earth rotates around its axis and revolves around the sun, we see the moon traveling around the night sky and getting either closer to or farther from our planet. What makes it bright yellow tonight and ominously dark red tomorrow is a more complex thing. The natural color of the moon, as seen from outside the Earth's atmosphere, is brownish gray. From the surface of our planet, though, it may vary a lot. When seen right above our heads, it usually looks bright and almost white, because its reflected light passes through a relatively thin layer of the atmosphere. Almost nothing blocks and refracts the shine, so it's very clear. The moon can appear yellow, orange, or even red when it's seen just above the horizon. The effect is similar to what happens at sunrise or sunset, when the sun appears to be red. The light goes a much longer way to reach your eyes from that location, and much of the blue part of its spectrum gets lost. This turns the color of the light into a much warmer variety. Our natural satellite can also appear blue, and the reason for that is the presence of fine particles in the air. They refract the light anyway, so the moon is actually never the way it looks outside the atmosphere. But when they're larger than usual, they turn its color bluish. Finally, there's an extremely rare occasion where the moon can look purple. Nobody actually knows for sure why this happens, but astronomers believe it must be a combination of the atmosphere, dust particles, and maybe something else. There's no clear explanation. Moonquakes aren't something from science fiction. They don't occur as often as on our planet, and when they do, it happens closer to the center of the satellite. Scientists think moonquakes might be caused by the gravity of Earth and the Sun. There are Mars quakes too. For a long time, the red planet had been considered tectonically inactive, but more recent observations have shown it still has weak quakes from time to time. You probably wouldn't even be able to feel them if you stood on Mars's surface, but it means some geological processes are still going on underneath the red and dusty landscape. There's no dark side to the moon. Our satellite is tidally locked with Earth, meaning it's always turned to us with one side, while the other always looks away. The sun is much farther from us than the moon, and we're both turning round and round, warming and lighting this side and that in turn. It means that once in every short while, the moon is lit by the sun from either side. It's just that we can't see it from where we are. Each year, the moon is moving away from Earth because of the interaction between the moon's gravitational force and our oceans. It moves around 1.5 inches away each year, which means in 600 million years, it will be 14,600 miles further from Earth than it is now. The number isn't accidental. That's the time when total solar eclipses will stop happening. There is water on the moon. Not puddles or lakes, but grains of water ice exist in permanently shadowed parts near the moon's poles. Scientists think water got on the moon a long time ago, during a period when both the moon and Earth were constantly struck by asteroids and comets. Those contain water ice. This process may have even helped us get our own lakes and oceans, not just the moon's icy water. Newer research says the moon's interior already had water, and it went to the surface during volcanic activity. The same might have happened on our planet too. For those of you who think the Earth only has one moon, there are 2 more asteroids locked into co-orbital orbits with our planet. The first one doesn't really circle around the Earth, but has some sort of a synchronized orbit with the planet. That's why it looks like it's following the Earth in a stable orbit, while in reality, it has its own specific path around the Sun. The other one follows a horseshoe orbit around our planet. Its specific path brings this asteroid closer to us every 95 years. The moon has its own time zone called Lunar Standard Time. Time is different on the moon, so a year there is divided into 12 days, considering each is as long as our month. Days got names after astronauts who walked on the moon. The moon calendar starts the moment Neil Armstrong stepped onto the moon in 1969. The crust of the moon is not equally thick in all its parts. The average thickness is about 31 miles, But there are much thinner and much thicker areas. This is sometimes due to craters found all across its surface, and there are also big hollow tubes underneath. A lunar orbiter found one such tube several years ago, and it's pretty enormous. Although the tube's shape is irregular, it could swallow an entire football field. Scientists are still unsure what they could find in its depths. It could be a tunnel system, or some geological wonder in there. The most popular explanation of this thing is that it's a lava tube, the likes of which can be found on Earth too. When a lava flow cools, it gets a hard crust, which later thickens and creates a roof over that same lava. It continues to flow, but when it stops, the channel can drain, which results in an empty tube. One of the few places you haven't traveled to yet is a volcano. It's an opening in the Earth's crust through which hot gases, molten rock, and other stuff get to the surface of the planet. But which one should you choose? There are different kinds of them. For example, shield volcanoes are built almost entirely of solidified lava flows, or lava domes formed by small masses of lava that are too thick to travel great distances. You can also pick a cinder cone. It's the simplest kind of volcano out there. It's built from blobs of almost solid lava that erupts from a single vent. This lava is ejected into the air with great force. Then it breaks into tiny fragments that become solid and fall back as cinders. With time, they form an oval or circular cone around the vent. Such cones rarely rise more than 1,000 feet. But what if you choose something even more impressive? How about traveling down a stratovolcano? Huge, steep-sided, and powerful. Once you've made your choice, you also decide to opt for an active volcano that is erupting at this very moment. What you're observing now is called a glowing avalanche. The volcano has just erupted a huge portion of lava, which has created a pyroclastic flow. Its temperature can reach an insane 1,300 degrees Fahrenheit. You see how this flow gets formed from rock fragments and surges down the flank of the volcano at a speed of several hundred miles per hour. Ash is raining down on Earth like grayish, powdery snow. Volcanic ash consists of tiny particles of pulverized rock, volcanic glass, and minerals. When the ash gets mixed with the water from mountain streams and rivers, raging mud flows appear. Despite how scary it all looks, you get closer. Good thing you're wearing a protective suit that can withstand any temperature. The nearer you get, the more fumaroles you spot. These are holes and cracks at the base of the volcano and in its slopes. They emit huge clouds of steam and volcanic gases, carbon dioxide and sulfur dioxide. Some of the cracks are so large, you can probably squeeze through and sneak a peek inside the volcano. But you have a different destination, the crater. On your way there, you spot a strange conical structure on the side of the volcano. It looks like a horn growing on the main cone. It must be a secondary cone, also known as a parasitic cone. Such cones form around secondary vents that reach the surface of large volcanoes. In this case, an eruption can occur not only through the main vent at the top of the volcano, but also through these additional vents. In any case, that's not where you're heading. Soon, you reach the crater. It's a massive circular basin. When you go to its edge and look inside, you see it's also very deep. The lava vent, which is where you need to go, is at the bottom of the crater. But even before jumping into the vent, you spot some strange tubes hiding under the lava flow. Those are lava tubes, natural passages through which fresh liquid lava travels beneath the surface of the lava flow. You decide to make a detour and follow one of the tunnels. It's the main lava tube. You also spot several smaller tubes. They supply lava to one or more lava flows. If the volcano wasn't erupting at the moment, the lava would drain downslope from this tube system. The passages would have lava marks on the walls, a flat floor, and lava stalactites hanging from the ceiling. But even now, there's some empty space above the flowing lava. That's because it has eroded downward, making the tube deeper. But right now, you need to get back. You take the next turn and get back to the crater. You wait till the volcano spews another portion of boiling lava and dive into the volcano's throat. It's the entrance of the volcano. Lava and volcanic ash get ejected from here. The volcano's throat is wide, and you easily travel deeper down. The lava around you glows bright red and orange. That's because when it first bursts to the surface, its temperature can reach 2200 degrees Fahrenheit. That's hot enough to melt iron. You move down the volcano's main vent. It's a weak point in our planet's crust. There, scorching hot magma manages to escape from its chamber and reach the surface. While going deeper and deeper into the vent, you notice sills. Sometimes, lava intrudes between the crack in the crust, pools there, and crystallizes. This creates deposits of ash and solidified lava. That's what sills are. Pretty soon, you reach a magma chamber. It's a large pool of molten rock. The one you're in at the moment is quite shallow. That's because it's not the main one. After traveling several more miles down through the vent, you get to another huge magma chamber. It supplies the small one beneath the base of the volcano. The main magma chamber lies in Earth's crust, which stretches from 3 to 44 miles deep. The molten rock there remains under extreme pressure, and the temperatures inside are incredibly high. With time, the rock surrounding the magma chamber starts to break and fracture. This creates outlets for the magma. And since it's made of a much less dense material than the surrounding rock, the magma begins to seep through the cracks to the surface. From the main chamber, it rises to the upper one. Then it makes its way to the surface in a powerful eruption. You explore the magma chamber and then decide to go even deeper than that, to the place from where all that molten rock gets into the magma chamber. You're moving through the crust. The volcano is located on land. That's why your trip takes longer than it would if you were traveling through the oceanic crust. It's only 3 to 6 miles wide. But the continental crust is much thicker. It can be 28 miles thick in some places. As you're going through the crust, you can't but notice its light color. That's because it consists mostly of granite. If you were going through the oceanic crust, the material surrounding you would be dark or nearly black because it has a different composition. The deeper you go, the hotter it becomes. Sure, the temperature here isn't as high as in the magma chamber, but still, at the boundary with the mantle, your thermometer shows 750 degrees Fahrenheit. At a depth of about 20 miles, you reach the boundary between the crust and the Earth's upper mantle. There, the pressure reaches a mind-boggling 10,000 atmospheres. That's where magma comes from. You could finish your journey and get back to the surface, but your curiosity gets the better of you. You decide to go deeper, all the way to the center of the Earth. The next layer on your way is the mantle. It makes up 2/3 of the Earth's mass and 84% of our planet's volume. It's 1,800 miles thick. The rock closer to the inner part of the mantle is semi-solid, like caramel candy. The upper part of the mantle, as well as the crust, is broken into massive pieces. They look like a colossal jigsaw puzzle. Those are tectonic plates. They drift at a speed of 1 to 2 inches per year. You're moving through the upper mantle and feel the temperatures rising up to 1,600 degrees Fahrenheit. Near the boundary with the core, the temperature is already as high as 7,000 degrees Fahrenheit. The pressure in the lower mantle reaches 240,000 atmospheres. You'd feel the same pressure if 3,300 elephants made a tower on your head. At a depth of about 1,800 miles, you see the boundary between the mantle and the outer core. The insides of the planet around you are heated up to 9,000 degrees Fahrenheit. Such temperature is high enough to keep the outer core liquid. The pressure there is almost 2 million atmospheres, but it's not enough to make the iron that the core is made of solid again. The outer core is 1,500 miles thick. It churns in massive turbulent currents and generates a magnetic field. In the outer core, Earth's magnetic field is 50 times more powerful than at the surface. You are now more than 3,000 miles underground, and you've reached the inner core. It's a solid metal sphere, around 1,500 miles across. The inner core is immensely dense and spins faster than the rest of the planet. The temperature there is as high as on the surface of the sun, 9,800 degrees Fahrenheit. And the pressure inside the inner core is 3 million times greater than on the surface. It took about 500 million years for the inner core to form, which means it's younger than some parts of the crust.
It's dark outside, almost 2 a.m. You go outside and look at the sky, and here it is. bright, full moon. You might think you know a lot about Earth's natural satellite, but let me ask you this. How did it form? The answer is, nobody knows. But of course, there are theories. The most popular one, called the giant impact theory, claims that the moon formed during a collision between Earth and another planet. This planet must have been smaller than ours, the size of Mars, and the collision itself probably happened around 4.5 billion years ago. Another theory, called the capture theory, claims that the moon used to be an asteroid or some other wandering body. It formed somewhere else in the solar system. When it was passing by Earth, it got caught by our planet's gravity. But here is one catch. Our planet and the moon have remarkable isotopic and chemical similarities. So, they must have a linked history, which means the moon couldn't have been created elsewhere. Other experts think that at some point in the past, Earth was spinning so fast that some of its material broke away. It soon started to orbit our planet. That's how the moon appeared in the sky. But again, there's one problem. In this case, the proportion and type of minerals on the moon would have to be the same as on Earth. But there are slight differences. The moon is richer in materials that form very fast at high temperatures. There's one more theory, and it's probably the least exciting. It claims that Earth's natural satellite could simply appear along with Earth during our planet's formation. Duh! But these days, a more urgent question keeps astronomers busy. Is the moon really Earth's satellite? Or are these two twin planets? The moon is big compared to our planet, about 1/4 of Earth's size. That's why some experts refer to our planetary system as a double planet. But how correct is that? If we want to figure it out, we need to give the definition to the word planet. According to the International Astronomical Union, a planet is a space body that orbits the Sun, is massive enough to have a nearly round shape thanks to its gravity, and has cleared the region around its orbit. Now, what about a satellite? It's an object in space that orbits around a larger celestial body. If we take the system Earth, the Moon, its center of gravity, called a barycenter, is inside the Earth. That's why at the moment we can't say that we live in a twin planet system. According to this definition, the Moon is the satellite of our planet. Now, let's get back to the past, like 3 or 4 billion years ago. Even though the Moon wasn't a planet, it most likely had a full-fledged atmosphere. It formed at times when powerful volcanic eruptions were rocking our satellite. Gases spread all over the Moon's surface, and it happened so fast that they didn't have enough time to escape into space. At that time, the lunar surface was covered with basins filled with volcanic basalt. Just imagine ginormous plumes of magma hurtling high into the air, falling to the ground and creating lava flows. That's how the basalt basins appeared on the surface of the Moon. At one point, scientists got their hands on samples brought from the Moon. They found out that lava flows there contained not only carbon monoxide and sulfur, but also the building blocks of water. Thanks to these samples, researchers managed to calculate the amount of gas that rose and formed the atmosphere. It became the thickest around 3.5 billion years ago and existed for about 70 million years. After that, poof, the atmosphere was lost in space. But the coolest thing? When the Moon did have an atmosphere, the satellite was 3 to 10 times closer to our planet. One computer simulation even suggests the Moon was probably up to 19 times closer than it is now. The distance between it and our planet could be 18,600 miles, while these days our satellite is around 240,000 miles away. That's why the Moon looked much, much bigger in the sky. Unfortunately, at that time, not even dinos were around to admire the view. These days, the atmosphere of the Moon is almost non-existent, and that's why the satellite can't protect itself from meteorites. The surface of the Moon is dotted with craters. For comparison, there are about 190 identified impact craters on our planet. Many of them are hidden by vegetation or covered with water. But if we speak about the Moon, the number is so much greater, several million. and around 5,000 of them are more than 12 miles across. And since the moon is less seismically active than Earth, these craters and other ancient formations stay in perfect condition for centuries. When you look at the moon, it's the brightest object in the night sky. But in reality, its surface is dark because the reflectance of our natural satellite is just a bit higher than that of asphalt. You might know that the moon's gravitational pull causes tides on our planet, making the oceans bulge out on both the side closest to the moon and the one farthest from the satellite. But that's not all. The moon also slows down Earth's rotation. This phenomenon is known as tidal braking. It increases the length of a day on Earth by a bit more than 2 milliseconds per 100 years. The moon is also moving away from Earth at the same rate at which your fingernails grow. That's about 1.5 inches per year. If one day the moon floats away into space, our planet will have to live through tough times. Without the stabilizing pull of the moon's gravity, Earth's tilt would start changing wildly, from no tilt at all, meaning no seasons, to a large tilt, resulting in extreme weather. Even though the moon's surface is mostly dormant, Earth's natural satellite still experiences moonquakes. One theory suggests that they may be happening because the moon is shrinking as its insides are cooling. Scientists say that the moon has become around 150 feet skinnier than it used to be several hundred million years ago. To help you understand it, picture a grape turning into a raisin. It wrinkles while shrinking. The same is happening to the moon. It's shrinking and it's wrinkling. But unlike the grape, the moon doesn't have flexible skin. Its surface is hard and brittle, so as the moon gets smaller, the crust cracks and breaks, and its sections get pushed over neighboring parts. Want to know another cool thing about the moon? A recent study claims that it has a tail. And every month it wraps around our planet like a scarf. This slender tail is made up of millions of atoms of sodium, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. For several days every month, the moon remains between the sun and our planet. That's when Earth's gravity picks that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full moon's diameter. And the spiciest fact for you, 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it was no larger than an average car, it was still a big deal. Out of more than 1 million asteroids astronomers know about, it was only the second one to orbit our planet, called 2020 CD3. It was our temporary mini-moon. It didn't stay with Earth for long, though. The asteroid followed a random orbit and slowly drifted away. Temporarily captured objects such as 2020 CD3 are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction. The moon, a beautiful, natural satellite with some mysterious dark splotches. We always see only one side of it, so we're used to this image. It's hard to imagine the moon looking any other way. But it used to be different. Oh ho ho, it used to be so different. Picture this, a huge incandescent satellite in the sky that is causing constant tsunamis. I suggest we go very far into the past to see what the moon was like many, many years ago. The moon formed around 4.5 billion years ago. At that time, our green-blue planet was still a red-hot, insanely unstable piece of rock flying in space. We didn't have the moon yet, and a day on our planet only lasted 6 hours, which meant only 3 hours of daylight. Volcanoes erupted all over the place, releasing poisonous gas into the air, and a bunch of meteorites regularly crashed into the planet. At the same time, 4.5 billion years ago, the so-called Big Splash occurred. or as scientists call it, the giant impact hypothesis. It claims that once an object the size of Mars crashed into Earth. Mars is about 2 times as small as our planet, so the blow wasn't too bad, but it was quite catastrophic. This powerful impact tore off part of the outer layers of that Mars-sized object and Earth. The very core of this space body merged with Earth's own dense core, and a huge number of fragments of Earth flew into outer space. So, this was the beginning of our moon, or, saying in a scientific way, the process of differentiation has begun. This is the process all planetary bodies go through at the beginning of their lives. Since the impact was very hot, its heat carried away most of the gases and liquids from the broken pieces of Earth. Only a relatively dry stone surface remained. So yeah, there is water and gases on the moon, but in very small quantities. The gravity of our planet was strong enough to make all these hot stone fragments stay in its orbit, and they gradually began to stick together. The chemicals they contained were distributed in layers. Iron, which was heavier, sank deeper inside, and lighter elements formed the surface. In a short time, 100 years or less, the ring of steam, dust, and molten rock fused together. The largest clusters with the strongest gravity attracted more and more particles, gradually forming the moon. It looked like a red-hot bubble ball. Sadly, the nucleus of this newborn moon turned out to be very small. It lacked iron and other heavy elements to form into something substantial, like a planet. The oldest rocks of the moon probably formed in the ocean of magma. And when the moon gradually cooled down, it turned out to be a white, clean, and perfectly even ball. But it was still completely different from what we have now. To begin with, immediately after its birth, the satellite was located at a distance of only 13,500 miles away from Earth. This is 15 times closer than it is now, around 238,000 miles. It's scary to imagine how huge and bright the moon looked in the sky at that moment. The view was probably both beautiful and terrifying. And, of course, such proximity caused incredibly huge waves on Earth. The planet experienced regular tsunamis. Also, at that time, the moon was spinning very fast, and it wasn't turned to Earth with only one side. But, in general, Earth and the moon had a positive impact on each other. For example, it was the moon that made our day last 24 hours. Now, Earth's axis is mostly tilted 23.5 degrees from the plane of its orbit around the Sun. Without the moon, Earth rotated rapidly, but thanks to the satellite, the planet's tilt stabilized, which led to a wide and pleasant variety of climates on Earth. To be fair, the gravity of our planet also helped the moon. Thanks to it, the moon began to rotate more and more slowly while gradually moving away from us. Over the years, its orbit has moved far away from our planet. At the same time, the moon became tidally locked to Earth. This means that its rotation period coincides with its orbital period. Or, in other words, the moon moves around itself as fast as it moves around the Earth. That's why the moon always faces our planet with only one side. When the moon moved away, tides on Earth became calmer. Now, water could flow to the most remote corners of our planet. It was then that life appeared on Earth. But back to the evolution of the moon itself. What was happening on its surface after its formation? The next stages of the moon's development were childhood and adolescence. And as is usually the case at this stage, this period was insane. No wonder. About 4 billion years ago, the solar system was going crazy. During the first 600 million years of the moon's existence, large asteroids and comets constantly collided with it. Now, they were bothering not only our Earth, but also its satellite. These impacts were the most powerful in the history of the moon. They left many large craters, which were later filled with dark rock. So, Earth wasn't enough for you, huh, space? Once, a dwarf planet crashed into the moon. It was about the size of Ceres, the largest object in the asteroid belt between Mars and Jupiter. This explosion formed the SPA basin and also forever changed the appearance of the moon. Can you see that dark spot on the far side of the moon? Right there in this very south? This spot is called the South Pole Aitken Basin. Its diameter is about 1,600 miles. And yes, it was formed by the impact I've mentioned about 4.3 billion years ago. This planet brought with it a bunch of complex and strange chemical compounds that scientists are now finding all over the far surface of the moon. These compounds began to emit a lot of heat, melted part of the lunar mantle, and, oops, accidentally woke up volcanoes. The volcanoes began to erupt furiously. A huge amount of magma was distributed over the surface of the moon. Many years later, it cooled down, leaving behind those famous dark splotches that we're so used to. They're called the lunar maria. There are much fewer craters there than on the lunar highlands. But for the last billion years, the moon has been geologically inactive, except for occasional collisions with meteorites. In general, the appearance of the moon changed forever as a result of these events, and, battered and tired, it entered adulthood. But even then, it couldn't get any peace. A bunch of meteorites decided to bother it again. Honestly, it wasn't that bad. There were many collisions, but all of them were quite small. They just left a bunch of craters and pits on the moon and maybe damaged its mantle a little. Some of the collisions deepened already existing large craters. The moon's crust was getting thinner and thinner over the years because of all the chaos going on. And now we call this upper part of the lunar crust covered with craters the lunar highlands. All those white and bright areas of the moon, the highlands. But in the end, the universe finally calmed down. For now at least, and the moon began to look the way it does today. There are still many things we don't know about Earth's natural satellite. There are moments in its history that scientists still can't accurately explain, but they're continuing to study our beautiful satellite. The data about the moon is useful to people not only for its own sake. It gives us a more complete picture of both the history of our solar system and space as a whole. So, let's hope that one day we'll be able to find out everything there is to know about the moon. Hey Mythbusters! Today we're debunking some classic space myths. Hop on the next space shuttle and let's get to the bottom of these tales once and for all. Picture this. You're floating weightlessly in space, sipping on a cup of delicious hot chocolate, when a peculiar thought pops into your head. Can you scream in outer space? And if yes, would anyone hear that scream?
If you've watched the movie Alien, then you know the answer to this one. You can't hear sounds in outer space.
It's not that sounds don't exist.
It's just that you can't hear them.
There's no one better to clarify this myth than Chris Hadfield. He's been on a couple of spacewalks during his life as an astronaut. And once you're out there in the darkness of space, you can't hear anything.
All you hear is silence. Complete silence.
But hey, just around the corner is a massive ball of explosion, aka the sun. We just can't hear the explosions happening because there's no medium for sound to travel through. It would be quite uncomfortable for an astronaut, though, if they could hear all the noises going on in outer space. Now, imagine you're zipping through space, feeling like a futuristic superhero, when a shooting star passes by your side. But wait, is it really a star? Unfortunately, shooting stars are not stars at all. They are small space rocks known as meteoroids, entering Earth's atmosphere and creating a stunning light show. Oh, and since we're debunking myths, let's head straight for another one. You've probably heard that meteors only crash into Earth on extremely rare occasions, like once every dinosaur extinguishing apocalypse. That's not true. Scientists estimate that about 48 tons of meteoritic material fall on Earth each day. But almost all of this material is vaporized in Earth's atmosphere. The bright trail we see in the night sky is what we popularly call a shooting star. Next time you make a wish upon a shooting star, remember, you're actually hoping on a tiny piece of space debris. It's not so romantic after all. Can we or can we not fly into the stratosphere on air balloons? Apparently, we can. The Earth's stratosphere starts relatively close to the ground, about 7 or 8 miles up from the Earth's surface, but it continues a long way up. If you were to fly yourself all the way into the stratosphere with some type of air balloon, just make sure you have really good equipment at hand. You'll need a special suit and some breathing devices because air starts to get pretty thin the higher you get. Of course, if you do go all the way up, you need to get a picture of the Earth's curvature. So take a chest harness with you where you can put a special camera or something like that. And how about you live stream the whole thing? That would be a first! Imagine it's been 102 days since you left Earth. You've adapted well to life in outer space, but something weird is happening to your body. You're getting taller. How is that even possible? Don't stress about it, it's completely normal. The truth of the matter is, you're not getting taller. This is what happens to your body when it's not under the effect of gravity. Our body has natural space between vertebrae and joints. On Earth, this space is almost completely squeezed due to the force of gravity. But in space, your body gets some time off of the pushing force of gravity and begins to stretch more and more. So yes, astronauts can grow up to 3% taller when they're on long missions. And here's a curiosity, NASA has that all covered when they're tailor-making spacesuits, of course. This way, astronauts will always have extra space in their suits. Once astronauts are back on Earth, the anti-gravity effect will wear off. So maybe they'll spend a few days wearing capri pants before it fits perfectly on their bodies again. Never have I ever pictured an airplane door bursting open mid-flight and a bunch of passengers being sucked into the atmosphere like flying feathers. Well, I'm betting most of you have had similar thoughts when getting inside a plane. Now imagine if this were to happen in outer space. Common knowledge says that if an astronaut is sucked out of an airlock, this person would be burnt to a crisp. Brace yourselves, because this is not only true, but the reality of it is way worse. According to astronaut Chris Hadfield, this is what would happen. The part of your body in the shade of the sun would experience temperatures of negative 418 degrees Fahrenheit, while the part of you getting sunlight would burn at around 480 degrees Fahrenheit. Your lungs would collapse, and your blood would start to boil like tea water. So you would burn, freeze, lose your ability to breathe, and boil. Yikes! How many times have you heard that astronauts have to work out every second of every day, otherwise they'll pass out? This is a complete myth. Remember we talked about gravity earlier? Due to the lack of gravity in outer space, our bodies don't have to do any heavy work. Our torsos don't have to sustain the weight of our heads, and we don't have to make any effort to move our legs because, essentially, there's no walking in outer space. Now imagine living like that for 6 months, or even a year of your life. Your muscles could turn into jello. That's why astronauts work out. They'll strap themselves and run on a treadmill, or they'll do some weightlifting in a special machine. This way, their muscles won't feel the lack of gravity too much. They do need to keep hydrated though. You know what? If I was an astronaut, I'd ask NASA if I could take my super soft water flask up into space with me. You've probably heard that space smells like burnt steak or barbecue sauce. Now, as much as this sounds absurd, this myth is more true than it is false. Astronauts obviously can't smell space when they're in it because they can't take off their helmets. They usually smell it once a space vehicle docks and they open up a hatch. Apparently, what causes this smell is the presence of hydrocarbons that float around in space. Who would have thought, huh? Hey smart people, let me ask you a question. Do you really think that if astronauts fly at the speed of light, they won't age a single second? I knew you'd say no. Let's get a few things straight. First of all, we haven't figured out how to operate vehicles at the speed of light. This would require an immense amount of energy, and we don't have the technology to do that. Second, even if we managed to send a human inside a spacecraft that traveled at the speed of light, this person would still age. They would age differently than the people who remained on Earth, that's a fact, but they would still age. Do you lot really think there's such a thing as immortality? Nah. If you've seen the first Avatar, then you certainly remember that humans only managed to get to Pandora because they traveled in Cryosleep. In other words, they froze their bodies. put them in a cryobed, and traveled for years without aging. Yes, this sounds amazing, but we still don't have the technology to do that. Our bodies are mainly made out of water, right? And when you freeze water, it expands. That's why you should never leave soda cans unattended in your freezer. Right now, if we froze a person's body, the water inside of it would expand, harming tissues and organs. So no, we can't cryosleep our way into interstellar travel. Not yet, at least. Here's a crazy thought. What would happen if an astronaut took a drone with him on one of their spacewalks? Unless it's a NASA-designed drone, maybe the thing would freeze and burn like humans would if they went into space without a suit. But hey, a person can dream, can't they?
Quakes Volcano in Indonesia is not your ordinary lava-belching mountain. Instead of producing black smoke and red lava, as most volcanoes do, this eccentric guy lets out a blue flame and electric blue lava. This phenomenon occurs because the volcano contains some of the highest levels of sulfur in the world, and when the sulfuric gases interact with scorching air and get lit by the molten lava, they start to turn blue. Unfortunately, you can see this mesmerizing sight only at night, but you can smell it all day long. By the way, the world's largest acid lake is also located inside this crater. The Dead Sea has a high concentration of salt and minerals compared to other seas, even though it's technically a lake. Swimming is almost impossible, but people go there for the natural chemicals for the body. Floating on the surface is a great way to relax. This ancient body of water got its name because no macroscopic organisms can live there since it's 9.6 times saltier than oceans. Only a few bacteria and fungi can be found enjoying the salt. It's also Earth's lowest elevation on land at 1,400 feet below sea level. An underground crystal cave exists in Mexico, and it looks like some interstellar world. It's roughly 1,000 feet beneath the surface, with each spike measuring up to 35 feet in length and weighing up to 55 tons. These are some of the largest crystals in the world. Luscantire Beach is an endless strand of white sand dunes and azure water. But don't let the tropical vibes fool you. It's located in Scotland. That's why it mostly looks like this during May and June only. In December, the place gets only an average of 1 hour of sunshine per day, making it way more dramatic and monochrome. The Georgia Guidestones is a collection of giant stones in a star pattern. It has inscriptions in 8 languages, including Hindi, Chinese, and Swahili. It also has an astronomical calendar finished in 1980 and was built to last centuries. No one knows who built it or why. All the way over in sunny California is Sequoia National Park, home to the giant forest. It's been around for thousands of years. More than 8,000 of these colossal trees rule the land, including 10 of the largest living plants in the world. The General Sherman sequoia is estimated to be up to 2,700 years old and is recognized as the world's largest known living tree by volume. The famous stone heads of Easter Island have been around for hundreds of years. No one knows exactly why they were built. Some scientists think that local people believe the statues would make the soil more fertile. Soil analysis proved the heads did their job well. It's the best agricultural spot on the island. The chemical composition of the ancient hot springs in Pamukkale, Turkey, makes the water pouring over the edge look magical. They're not only good for cleansing your body, but the mind too. All the way in Saudi Arabia is a rock sliced perfectly in the middle with 2 pieces sitting parallel. What makes Al-Naslaa so unique is that it wasn't artificially done, but is a result of nature's work over the years. Now, this glacier may look like someone dropped tons of red paint in the middle of Antarctica, but it's actually the natural color. Blood falls is a result of extreme salted water mixed with iron oxide, giving out this eerie vibe in the middle of nowhere. In early May 2018, New England observed one of the scariest and most dangerous phenomena ever, a super long-track tornado. The frightening natural phenomenon started not far from Charleston, New Hampshire, and traveled toward the town of Webster in Merrimack County. It took the tornado 33 minutes to cover 36 miles and become the 3rd on the list of the longest track tornadoes in New England. In the Philippines, You can swim in some of the most crystal clear waters and discover an underwater world below you in the province of Palawan. The municipality of Coron has white sandy beaches with many small boats riding through the many amazing sceneries. Tristan da Cunha is a small volcanic archipelago in the Atlantic, with the only neighboring cities of Buenos Aires, Argentina, and Cape Town, South Africa. It takes 7 days by ship to get to this unique place. If you want to escape from the rest of the world, staying with the 280 locals will make you feel like you're away from everything. During the first week of January 2018, unusually cold weather in the northeast United States froze the Atlantic Ocean in North Falmouth, Massachusetts. What's more, the ocean was frozen so thoroughly that people were walking on the waves. Now, that's obviously something you don't see every day. Red sand is what makes this beach unique and why tourists flock to Tianjin, China. A red-colored plant called a sueda salsa dwells in the saltwater. The whole beach is covered in red, with only the top layer of the sea visible. If there ever was a thing that said, "I defy gravity" out loud, it's the stone of Davasco in Argentina. The huge 300-ton boulder stands precariously on the edge of a cliff and rocks a little bit from side to side in the wind. People even checked it by putting glass bottles under one of its edges. They exploded with another movement of the rock. Unfortunately today, you can't see this wonder of nature as it was a century ago. In 1912, the boulder suddenly dropped from its perch, which it had occupied for literally hundreds of years. The people of the nearby town of Tandil were so sad about this event that 95 years later, in 2007, they decided to restore the stone. They made a plastic replica of the rock and put it on the same spot and even in the same position. So, even today, coming by Tandil, you can see its famous balancing boulder. More of a symbol now, of course, because it's no longer rocking and only weighs 9 tons, but instantly recognizable nonetheless. Socotra is an alien-like island off the coast of Yemen in the Indian Ocean with one of the most unique trees ever seen. It's called the dragon tree, and it can only be found on this amazing island. In 2008, it was labeled as a World Heritage Site. If you ever see a tight burning column of air, don't panic, it's not the end of the world. The creepy combination of whirlwind sounds and scorching inferno means that you have crossed paths with a fire tornado, also known as fire twister or fire whirl. This dangerous phenomenon occurs mostly during wildfires. These fires create a big area of super hot air just above the ground. When this scorching air gets mixed with the cooler air higher up, it results in a whirlwind that churns up burning debris and flames. The most powerful firenadoes can stretch hundreds of feet into the air. The House of Mystery in Gold Hill, Oregon, amazes its visitors with gravity-defying effects. You can't stand straight there, always leaning to the side and having to hold on to something for balance. Balls roll upwards. There's also a broom that stands perfectly still wherever you put it, unlike virtually everything else in the shack. The local Native American tribes called this place the Forbidden Ground, even before the house was built there, and they avoid approaching it. The owners of the shack, though, decided to turn it into an attraction, and they succeeded. They created an atmosphere of mystery around the place, and spread the news about it in newspapers and later on the internet, and voila! A perfect anomaly is made. In fact, it's no more than a curiosity. A human-made optical illusion that tricks your eyes and other senses. Now, if you travel to the Philippines, Indonesia, or Papua New Guinea, you'll have a chance to see some of the most unusual and cheerful trees in the world. The trunk of the rainbow eucalyptus looks as if it had been painted orange, green, red, purple, yellow, brown, blue, hey, you name it. Some trees are so bright that they seem artificial. The rainbow eucalyptus regularly sheds strips of bark, which reveals a bright green layer underneath. A bit later, this green layer gradually changes its color, and since the shedding happens at a different time in different places on the trunk, the tree starts to look multicolored and very attractive. Yemen is home to the oldest skyscrapers in the world and the oldest metropolis. The ancient city of Shabam is considered to be the Manhattan of the desert, due to the collection of mud buildings popping out of the desert floor. It used to be a caravan stop during ancient times. Hey, ready to test your knowledge? Of course you are. You'll get 1 point for each correct answer. So, without further ado, the sun is yellow. Do you think this is a myth? Ask someone to draw a picture of the sun, and chances are you'll get a yellow or orange circle in the sky. Surprise! The sun is not really yellow. If you see it somewhere outside the Earth's atmosphere, it'll look white. How come? According to NASA, the sun's temperature is the reason why it's white. The sun consists of all colors mixed together, so it appears to our eyes as white. Then why do you think we see it as yellow or orange from Earth? Colored wavelengths, which are yellow and orange, are longer, and they are the only ones that make it to our eyes. The other short wavelength colors sprawl in the atmosphere, and the sky looks blue to us during the day for the same reason. Meteorites are hot as fire when they land on Earth. What do you think, myth or fact? When people see a fireball around a meteorite, they think it's super hot. Well, this is a myth. Meteorites don't immediately land on Earth. Most of them have been in space for billions of years. Space has a cold environment, just a few degrees above absolute zero cold, you know. But don't meteorites fall into the Earth in flames? How come? The fireball is actually the air in front of the meteorite. It is compressed by the super high speed of the meteorite. The outside catches fire, but that layer is burned off on impact as a result of landing on Earth. As you would probably guess, when they land, the meteorites are lukewarm at most, but not as hot as lava. One side of the moon is permanently in the dark. Do you think this is a myth or a fact? This is a myth. Oh, come on. First the sun and now the moon. Am I living a lie? So, people look at the sky and see only the bright side of the moon. The reality is the Earth shines equally on all sides of the moon as it rotates and orbits the Earth. Half of the moon is in shadow, and half gets sunshine similar to Earth. That's not true. Similar to Earth, it doesn't have a permanent dark side. The logic is simple. The moon orbits Earth, but it also rotates on its own axis. When you think about it, we're always looking at the same side of the moon. Black holes take in everything that comes their way. What is it, myth or fact? Black holes don't have infinite mass and gravitational force, but still, no one really knows for sure what happens to the things pulled into them. Experts do know black holes do not have supergravity, though. Let's imagine this. If there was a black hole as big as the Sun, it wouldn't immediately eat the whole planet. Imagine black holes as vacuum cleaners. It does draw in a cloud of dust near its range, but other specks of dust remain where they are. So even if there was a black hole replacing the Sun, all the planets would continue to orbit similarly. They wouldn't go into the black hole. If a star or something else got into the range of the black hole, only then would its gravity affect the star. When you call someone, the signal bounces off a satellite. Is this a myth or a fact? Yep, it's a myth. Or rather, an urban legend or misconception, you name it. I mean, there are some satellite phones, but we, regular people, don't use those every day. Although your mobile phone works in a much different way. When you call someone, the nearest tower connects you to the other person online. This is why there are tower connections, huge networks of tower-to-tower connections, and hidden cables. The moon has no gravity. Any guesses? Myth or fact? This is an urban legend. Ask any astronaut you know. If you don't know any, just trust me. There is footage proving that the moon has gravity. When I say the moon has gravity, don't think it's similar to the gravity on Earth that makes the apple fall. The moon's gravity is only about 1/6 of Earth's. How does it feel to walk on the surface of the moon? The second man on the moon, Buzz Aldrin, mentioned it's like moving in slow motion and, quote, perhaps not too far from a trampoline, but without the springiness and instability, end quote. The sunset on Mars appears blue. Do you think this is a myth or a fact? This is a fact. Magnificent sunsets. The sky is filled with different shades of yellow. Now imagine this in blue. According to NASA, sunsets on Mars would look bluish, watching them with bare eyes. It's because of dust. Dust particles closer to the sun appear in blue tones. There is something called moon quakes. Does it sound like a myth or a fact? It's a fact. Quakes happen on the moon too, and they're called moonquakes. They have different features, not really similar to the quakes on Earth though. A planet can be hot enough to vaporize rocks. Any guesses? Is this a myth or a fact? This is a fact. The temperature in this universe is indeed very high. There's a planet, the temperature of which is enough to melt and even vaporize rocks. It's 2 times bigger than the Earth. This super-Earth is similar to our planet, but it is way too hot. Experts believe that it possibly has oceans of lava and clouds that rain molten rock. 1 million Earths can fit inside the Sun. Do you think this is a myth or a fact? This is a fact. Although the Sun is one of more than 100 billion stars in the Milky Way, which is at the heart of our solar system, it can fit 1 million Earths. Yeah, it looks small when we see it from here, but it's only because it's so far away from Earth. All comets have tails, myth or fact? It's true. Some comets simply don't show their tails. They look like someone threw a snowball into space. Space is completely silent. What do you say? Shh, I knew it was too easy. This is a fact. Space doesn't have an atmosphere, so there's no way to hear any sound there. Mercury is the hottest planet. Myth or fact? Mercury is the closest planet to the Sun, so this should be a fact, huh? No, not really. Venus is the hottest planet in our solar system and the second planet from the Sun. But the distance from the Sun isn't what defines the temperature. The heat depends on the atmosphere. So Venus's atmosphere consists mostly of carbon dioxide and some nitrogen. This combination makes the atmosphere very thick. When I say thick, I mean it. Throughout the year, the surface of Venus maintains a temperature of around 860 degrees Fahrenheit. Mercury's surface resembles the temperature of a desert, but is much higher in terms of temperature variations. Venus spins clockwise. What do you say? This is a fact. Venus spins in the opposite direction compared to many other planets. The Sun rises in the west, and its rotation is very slow. Venus needs 225 Earth days to complete its spinning around the Sun. The planet's distance from the Sun affects the duration of one rotation. It's too close to the Sun, and the Sun has a strong, noticeable pull on the planets. Footprints on the Moon can stay there for millions of years. Do you think this is a fact or a myth? Fact checked. The Moon has no atmosphere, so there's no wind blowing, and without the wind, there's no way to erase the footprints without any intervention. So, how many points did you get? Let me know in the comments. Guess what? The universe can get actual scars, just like when you fall off a bike. Well, here's why. Before the Big Bang, the universe was extremely hot, dense, and full of energy, and it seemed like everything was going well, until that all changed about 13.8 billion years ago. Then the universe exploded. After the blast, it expanded incredibly quickly. Our human brain can't even perceive how fast that expansion was. Sometime later, the universe started cooling down. As it did, giant, terrifying scars cutting through space-time appeared all over the place. And if we study these scars well, we can even get insight into time travel. These days, we call these scars cosmic strings. They're like stretch marks that appear when the skin expands too quickly. Or we could also compare them to cracks that form in the ice when it freezes. These strings are likely very thin, about the size of a proton, a positively charged subatomic particle. Yes, subatomic means smaller than an atom. The strings are also extremely dense and can stretch for light years. Now, imagine these cosmic scars floating through space, not interacting much with their surroundings. When two cosmic strings pass each other, they could warp space-time in such a way that it creates a time machine. If you were to travel along a certain path around these strings, you would end up returning to your starting point at an earlier time, which is traveling back in time. Now, let's admit it, this idea sounds like something from science fiction. But it's supported by cosmic string theory, and the math behind it seems to work. Unfortunately, no one has observed cosmic strings yet, so for now, it's still a theory. In 1991, one physicist proposed an idea for how cosmic strings could enable time travel. If two infinite cosmic strings passed each other in parallel, they would warp space-time, creating a time loop. This loop would allow someone to travel back in time. Even better, this idea doesn't contradict Einstein's theory of general relativity, which suggests that large objects can bend space and time. These bends in space-time could allow a shortcut through time. His now well-known concept of closed time loops also helps explain how wormholes might work. So, a wormhole is basically a theoretical tunnel connecting one place in space to another. Some people believe that by using such tunnels, we could create shortcuts for incredibly long journeys through the universe, which would allow us to visit other star systems and galaxies. So, let's say you manage to create a wormhole and even accelerate one of its ends to near the speed of light, and then you send it back to where it came from. Well, at that moment, those two ends are not synced anymore. One is in the past, while the other is in the future. And if you somehow manage to walk between them, you'd be time traveling. You could do something similar by placing one end of the wormhole near a powerful gravitational field, like a black hole, and keeping the other side near a weaker gravitational force. This way, according to the theory of relativity, time would pass more slowly nearer to the strong gravity side, and it would allow a particle or another chunk of mass to remain in the past relative to the other side of the wormhole. At the same time, if you decided to create a wormhole, you'd have to keep in mind that they are super dangerous. They might collapse all of a sudden. They're likely to be highly radioactive, or you could come into contact with toxic exotic matter inside. But let's get back to the math behind the cosmic string time machine idea. Admittedly, it is solid, but it doesn't mean such a time machine is possible yet. To use this way of time travel, we'd need to reach near light speed, and it might be impossible. According to Einstein's relativity, the faster an object travels, the more energy it needs to continue speeding up. In other words, we don't yet have the technology or energy sources to accelerate a spacecraft to these speeds. The idea of two infinite cosmic strings is also questionable because we can't create something that's infinitely long. So, while this time travel model is mathematically sound, the infinite nature of the strings would make this exact model impractical. At the same time, some scientists still believe that cosmic strings are a better possibility than most other models, like wormholes. In any case, before we can start considering time travel, we need to discover cosmic strings. Luckily, there's a group of astronomers working to detect low-frequency gravitational waves by measuring signals from a type of star called a pulsar. Now, pulsars send out regular pulses of radio waves, and by measuring small changes in the timing of these pulses, scientists can detect subtle shifts in space-time. Those changes are caused by gravitational waves, which are ripples in space-time. Now, so far, we've only detected gravitational waves coming from black holes. But in 2020, there was one strange signal that didn't look like it came from black holes. It could be coming from cosmic strings. And here, we need to mention string theory. According to it, the universe is made up of more than just the four dimensions of space-time. There are additional dimensions that are hidden from us. Plus, the basic building blocks of the universe aren't particles, but tiny vibrating strings. These strings can vibrate at different frequencies to create different fundamental particles. These strings, from string theory, could have stretched out during the early universe and become the very cosmic strings we've discussed. In the coming years, we might get more information about them from a space-based gravitational wave telescope called LISA. It's supposed to launch in 2035. But if the signals picked up in 2020 really came from cosmic strings, it could mean a huge breakthrough in physics. In this case, string theory would become the right framework for understanding the universe. It would completely change the way we think about the building blocks of our reality. On the other hand, even if the signals don't turn out to be from cosmic strings, this discovery would still be important. It would give scientists more information on what cosmic string signals might look like in the future. And while we're not yet at the point of time travel, the discovery of cosmic strings could take us one step closer to understanding the mysteries of the universe and maybe even the possibility of traveling through time. Now, time travel is a popular theme in science fiction, but in fact, moving forward in time happens naturally. Right now, you are traveling into the future at a steady rate of 1 second per second. However, scientists have discovered that this rate can change depending on speed and gravity. Einstein's special theory of relativity explains that time slows down as an object moves faster. The closer you get to the speed of light, the more slowly time passes for you, compared to someone who isn't moving at all. The general theory of relativity adds another factor: gravity. The stronger the gravitational pull, the more slowly time moves. Near massive objects, such as the surface of a neutron star, black hole, or even Earth, time runs more slowly than it does far away from these space objects. If someone were to stay near the edge of a black hole, where gravity is incredibly strong, only a few hours might pass for them, while thousands of years would go by for people on Earth. If they returned, they would have effectively traveled into the future. This is a real and scientifically proven effect. A real-life example of time travel, though on a tiny scale, can be witnessed in space missions. For example, this cosmonaut spent a total of 748 days aboard the space station Mir during 3 separate missions. Because Mir was moving at high speeds relative to Earth, it experienced time dilation. As a result, he aged 0.02 of a second less than had he stayed on the ground. Now, this difference may seem tiny, but it shows that time moves differently depending on speed and location. But while traveling to the future is scientifically possible, traveling to the past is much more complicated and controversial, and leads to logical paradoxes. Imagine you throw a billiard ball into a time machine. It travels to the past and collides with its earlier self. This prevents the ball from ever entering the time machine in the first place. A contradiction.
The universe is not static. It evolves all the time and grows in all directions. It's expanding, and scientists found this out almost a century ago. And it's not at a stable rate. The more time goes by, the faster the universe expands. As this happens, stars, planets, and galaxies move farther and farther apart, which leaves more space between them. If that's the case, the universe is supposed to become colder as it expands, right? After all, it was a lot denser when the Big Bang happened, and a lot hotter. As it was expanding, space was cooling down, which created conditions for planets, stars, and other space objects to form. Yeah, that's not exactly the case now. Scientists were surprised to hear it too. But our universe is actually getting hotter. They observed the temperature of cosmic gas farther away from our home planet compared to young gases closer to the Earth. Since we measure distance in space by light years, farther areas are like going back to the past, and regions closer to us are like observing the present day. They found out the temperature of a gas in space has gone up more than 10 times in the last 10 billion years. Now, the temperature of the cosmic gas that's spread all across the universe can get to around 4 million degrees Fahrenheit. Wow! As the universe expands, gravitational force does its part and pulls gas and dark matter together. It's doing some pretty hard work there. It creates galaxies and clusters of galaxies out of them. And this process is totally chaotic. It's so messy that more and more gas heats up as all of this is happening. Space was extremely hot when it was just forming 13.7 billion years ago. What if it gets warm like that once again? Scientists are observing the situation. They found out the temperature in space increased by measuring cosmic gases using something called redshift. They generally use this method when they want to see how far away some space objects are. Those that are closer to us have shorter light wavelengths. The farther some object is, the longer its light wavelengths are. And they can now determine the temperature of a certain object from its light. On average, space is a pretty cold place. The glow that's left from the Big Bang is called the CMB, which is short for the cosmic microwave background. It's so powerful and intense, it bathes the entire universe in light. It's the only thing that significantly heats up matter. But there are many smaller mechanisms that help to heat up matter in the universe, and they could go crazy if space warms up, like stars. They emit radiation that affects nearby dust and gas. They radiate throughout the far infrared too. When a star is at its early stage, the radiation coming from it forms protoplanetary structures that look like disks. They primarily form in a single plane, and a bright central star produces spectacularly illuminated gas, and there are blue reflections of this gas. It was like that with our planetary system too. Strong energy and gravitational forces cause collisions, dust, and gas in an uncontrolled vortex that's forming planets. That's why most planets in our solar system orbit in the same direction. That's the direction this giant whirlpool was spinning a long time ago too. Active stars, colliding galaxies, stellar cataclysms, black holes, neutron stars. The universe has so many sources of energy. And when you surround normal matter in space with such an energetic environment, it heats up drastically. When you heat something up, it radiates that energy away in a certain way. In most cases, galaxies have just a couple of areas where stars are forming, at regions where gas is collapsing. A bubble that surrounds that area contains ionized hydrogen. 3/4 of our sun is hydrogen. Thanks to that hydrogen, the sun keeps us warm. In its core, hydrogen transforms into helium and causes atomic fusion. Yep, that's how our sun releases its energy. Radiation heats all that gas to thousands and thousands of degrees. At the same time, it ionizes a large number of atoms and molecules, which basically means it turns them into ions. Atoms are neutral particles, and ions are either negatively or positively charged particles. If the universe heats up, our sun might too. If its temperature hits 30,000 degrees Kelvin, it could become hot enough to ionize all those materials it had previously ejected, and it could create a real planetary nebula. This would be a nebula in the shape of a ring that forms because of an expanding gas that surrounds an aging star. As the temperature goes up all the time, hydrogen ionizes. At a few thousand degrees, this could turn the nebulae in our solar system pink with emission lines. Our sun could come to its end if it reaches the temperature of 50,000 degrees Kelvin. If you could float in space and come closer, you'd see it glow in eerie green tones because of doubly ionized oxygen. Higher energy phenomena make more galaxies collide. This heats gas even more and eventually results in X-ray emissions. What about black holes and radiating neutron stars? When they go crazy, they can shape whole galaxies, and who knows what more. Maybe we'd have more masers too. Those are natural lasers our universe produces. They arise when big populations of molecules receive large amounts of energy. By now, scientists have found the strongest, yet the most distant maser. So powerful, it's more luminous than the light 6,000 suns would produce, and in just one emission line. Maybe then we'd discover even stronger masers. That's in the case that we are even going to be here at all. Because as the universe is getting hotter, cosmic radiation is getting stronger. Not so good for life on Earth. Increased cosmic radiation could harm us. Who knows if life would even be possible on Earth in that case, or if the powerful gravitational force would pull our home planet too, and crash it into another one. But maybe life as we know it wouldn't completely disappear. Or, if that happened, it could possibly somehow find its way once again, maybe in the distant future. There's a possibility our universe could support life at its early stages. Doesn't look like that when you think of the chaos the Big Bang caused, right? But that was only in its mere beginnings. After things had settled down a bit, the dregs of enormous, earliest stars formed rocky planets. In our solar system, those are Earth, Mars, Mercury, and Venus. You can't set your foot on the rest of them since they're gas giants. Back in that time, radiation was quite intense, so rocky planets had an adequate environment to form, since it takes a lot of energy to whirlpool dust and particles and bake a planet in the end. This period of time coincides roughly with that when the first stars formed in our universe. Ancient stars were way bigger than our sun. They lived shorter though. They would have just exploded as supernovas on their end, and they would leave heavy metals across the space around them. Those are the particles rocky planets formed from. Radiation spread around the whole universe back then. It has changed over time. Today, it's almost an absolute zero. 400,000 years after the Big Bang, when hydrogen atoms were forming, CMB was almost as hot as the surface of our sun. And about 15 million years after the Big Bang, its temperature was close to room temperature, which is around 80 degrees Fahrenheit. These things were happening across the universe, so there were many planets that could potentially hold life. If we were one of those ancient worlds, we wouldn't need a star to keep us warm. CMB would be enough to do it. So, it's possible that life in space is way older than we think it is. There could have been ancient worlds with liquid water on their surface. What if there were some primitive forms of organisms, like on our home planet a long time ago? Or even more developed ones? Perhaps we'll find out one day.